So I noticed I was sitting here blabbering on about what I was doing all by myself. I do that sometimes. I was just blabbering on about, oh, this and that. And I figured, oh yeah, that'd make a great video. That'd make a great video while I'm developing AddyCMOS. So what I've got so far is right here this is some code from simpmon that I noted down for what I want to make better. So I took 3 lines of really shit code that I'm just modifying to make it faster, because I learned that there's this thing called unique. It's a command and it gives you a unique output basically. So here's the explanation. Okay, so for, let's see, the model of the CPU, an example for simpmon. So for every core, the model is copy pasted basically in proc CPU info, which is where I get a lot of the information. It's copy pasted. So you have the model, like for every core, you have 24 different versions of what the model says for how many cores there are. It's the same thing, just repeated over and over. So, and then I was thinking, oh, well, to get one version of that, like just the one version, so I can get the information and not have like 20 different outputs, just one model version, you know, because it's all the same per core. To get one thing of that, I do tail-n1, which is actually dumb. And what tail-n1 does is whenever you have a lot of data, and all the same or all different, when you have a lot of data, if you want to see only the bottom of what the output of that data is, you use tail. And then -n1, you get the last line. You get only one line from the bottom. Head is similar, it's the opposite. Head is, oh, if you want the first line of a file, you use head. That's what you do, you use head-n1. Or set11q, some people do that. Set11q gives you like the first 10 lines, which it's the same as head-n10, but that's out of scope. Anyway, head and tail do very similar things. One does the top of the file for how many lines you want to output. One does the bottom of the file for how many lines you want to output. So I'm getting the very bottom line of what comes out here for the model name, which is kind of dumb. And the way tail works is, okay, visualize it. You have the number 5 going just down constantly. It's just going down. You have a log file or whatever. It's just going down. And you have 20 different versions of that same 5. What tail-n1 does is it looks through the whole file to find where the bottom is. It goes to the bottom, and then you get the last line of that file, even though it's all the same number. You don't need to do that. You just need to pipe this output into unique. Unique just goes, if it's the same, just give me one of them. You know, if it's the same, give me one of them in the file. Oh, you have 3 5s? Well, I want the output of, okay, so this wants to output it wants to output and it's 5, okay. And then unique is like, hey, I don't care how many 5s you have. If it's all the same, just give me one. Like, you know, that's what it does. It just gives you one. Doesn't scan the whole file. It's just like, it just sees if there's repetition and then gets one. And then this said stuff. This is fine in the awk. This is fine right here. But the tail-n1 was actually a big slowdown. There's like a little 1% difference between the two, but it's shell script. Shell script is slow. But the only reason I'm using shell script is because it's very portable if you write it correctly, if you write it POSIX compliant. And I want simpmon to be very portable. Not, you know, completely portable where you can use it on a vacuum cleaner, but I want it to be portable because I have a lot of machines running different Linux distributions, or I did. And I like to have the option to where even I can use it on my Raspberry Pi right here. This is my Raspberry Pi I've been using for development. I can actually use the script on here and it gives me a lot of the information. A little buggy because the proc CPU info output's not the same, but it still works. So yeah, that's what tail does. That's why I'm changing it to unique here. And I'm actually also looking through my miner setup.sh section just to see if I have any terrible code I need to fix. And a lot of it's actually okay. I haven't been like, oh, that's dumb. I've been like, oh, that's fine. I don't see any better way to do it. I haven't found a better way to do it yet. So a lot of this is all fine. It's good and dandy. I don't really like that it's all if statements, but that's really all you can do, because you need the logical statements for, oh, you know, if it's this, that, you know. You need those logical statements. And something that I noticed, and I didn't think it was that big brain at the time, I thought it was pretty dumb, was this RM log path right here. Log path is the path to the log.txt file, which simpmon gets if it's enabled for information. And basically what I do with the RM log path here in the pre-setup section is I don't want the log to be confusing if you're running the miner setup sh script again, in case you're debugging or you're working on something, in case of any of that. So I removed the log file because you don't need it if you're changing the config again. That's why I have it, you know, copy a new config here. Copies a new configuration file because you're changing the config. So it gives you that blank config. So the RM log path, it's kind of like a pseudo if statement in a way. If the log file doesn't exist, it just goes, oh, this doesn't exist. I don't have to do anything. But if it does exist, it does delete it. And I suppress the output because you don't need to see the output. So it's kind of like a pseudo if statement. And I didn't realize how good that was at the time. I thought it was pretty dumb because it's like a little stupid hack, right? But yeah, I've been looking through the shell scripts, being like, okay, what can I improve? What can I make faster? What can I make more efficient? Because it's shell code, you need to make it efficient. Even though something like this script you'll run once in a blue moon, but simpmon, you'll run it all the time if you're watching your machines. If you're like me and you need to watch your machines constantly to make sure they're running properly. That's why I'm going through the code, making it more efficient. And once I go through simpmon and all my code and see if I can make it more efficient, once I do make it more efficient, I'm actually going to release AddyCMOS version 1.0. Release, not alpha, not beta, no beta, no alpha no more. I believe it's stable enough for a release because I've been running it on my machines consistently without issues. I've actually had more issues with Debian than I have had with AddyCMOS during development. Debian has given me more problems than anything. I just hate using it. And I came up with maybe an idea today to get GPU mining working on AddyCMOS. It's kind of a hack. I don't know if I'll do it, but I've thought about it. Is what if I make a chroot image, basically a chroot image that runs the NVIDIA miner and all that, and runs CUDA, you know, it has all that in it, and it has glibc, because Alpine works on Musel. It works on that kind of library, while most Linux distributions work on something called glibc. Musel and glibc are not very compatible with each other. You actually have to have cross compilers for them, like it's a totally new architecture, because it kind of is in a way. They both kind of interface with the kernel. They do some kind of low-level, high-level stuff for software. If you compile a piece of software with a Musel compiler and then you try to run it on a glibc system, you're going to have issues, and vice versa. It's just going to not work. because the binaries aren't the same. But the reason Alpine uses something like Musel is because Musel is a lot more minimal than glibc. It doesn't require as much disk space or resources to run or use. So yeah, I'd have to do like a Chroot thing to get the NVIDIA mining stuff working on a Musel system, and that Chroot would have to include glibc. Now, I don't know if I'm going to use an Ubuntu minimal image to base the Chroot on, or if I'm just going to pull an LFS Arch Gen 2 and then make my own from scratch, which would be maybe a nightmare, but it'd be a fun project. So that's what I've been up to today. Just working on this crap code and fixing it up, and maybe I'll release AddyCMOS version 1.0 here soon. I haven't made too many changes to the system itself because it's so stable. I don't need to fix it as much anymore. It just runs reliably. It runs better than the notable Debian stable distribution, which I find kind of funny. So yeah, that's what this has been. You know, I'm going on my ramblings a bit, but I figured since I was already rambling here by myself, I might as well ramble on a recording and then post it up on YouTube. So yeah, that's basically this devlog. Talked about everything I had on my mind at this second.